Hello everyone, welcome to this tutorial on PySpark SQL's isNull and isNotNull functions. In this video, we'll explore how to handle null values in your dataset using these powerful functions. Null values often represent missing or incomplete data, and managing them effectively is crucial for accurate data analysis and transformation. By the end of this video, you'll understand how to filter, count, and manage null values efficiently in PySpark. Let's dive in and get started. Introduction to isNull and isNotNull functions. The isNull and isNotNull functions in PySpark are essential tools for handling missing or undefined data in your datasets. These functions allow you to check whether a column contains null values isNull or non-null values isNotNull. Null values in datasets often represent missing, incomplete, or undefined data, which can arise from various sources during data collection or processing. Properly managing these nulls is critical for accurate data analysis and transformations, as they can affect calculations, aggregations, and filtering operations. The isNull function is used to identify rows where a specific column has null values, which helps in flagging missing data or performing operations like replacing nulls with default values. On the other hand, isNotNull identifies rows where the column has valid, non-null data, allowing you to focus on rows that contain meaningful information. In data workflows, it's common to deal with incomplete datasets where some fields are missing or left undefined. These functions make it easy to filter out or work with rows based on the presence or absence of null values, ensuring that your data transformations and analysis are robust and accurate. Basic syntax. The basic syntax for using the isNull and isNotNull functions in PySpark is straightforward and helps you handle null values effectively. The dataframe.filterColumn.isNull syntax is used to filter rows where a specified column contains null values, while dataframe.filterColumn.isNotNull is used to filter rows where the column contains non-null values. These functions allow you to easily identify and manage rows with missing or defined data. The isNull function is especially useful when you want to locate rows with missing or undefined data in a specific column. It enables you to isolate these rows for further processing, such as replacing null values with a default value or analyzing the extent of missing data in your dataset. On the other hand, the isNotNull function is used to filter rows that have valid non-null data in a particular column. This can be helpful when you want to focus only on rows that contain meaningful, complete information and exclude rows with nulls from your analysis or transformations. Why use isNull and isNotNull? The isNull and isNotNull functions in PySpark are essential because null values in datasets often indicate missing, incomplete, or undefined data that requires special handling. Null values can arise from various sources, such as errors during data collection, incomplete entries, or inconsistencies in data integration. Failing to manage these nulls properly can lead to inaccurate results in your analysis or transformations, which is why it's crucial to identify and handle them appropriately. Using isNull allows you to pinpoint rows in your dataset where a particular column contains null values. This is especially useful when you need to apply specific rules for handling missing data, such as filtering out these rows, filling in default values, or flagging them for further investigation. By isolating these rows, you can ensure that nulls don't skew your calculations, aggregations, or data insights. On the other hand, isNotNull helps you focus on rows where the data is complete and meaningful. This function is useful when you want to exclude rows with null values from your analysis and work only with valid, non-null entries. This can improve the reliability of your results by ensuring that null values do not affect your data transformations. Practical examples. 1. Filtering rows with null values. In this example, we are using the isNull function in PySpark to filter rows where the sales column contains null values. The data frame df contains two columns, product underscore name and sales, where some rows have missing or undefined sales data represented by non-null. Our goal is to isolate the rows where the sales value is null. We achieve this by applying the filter method along with the isNull function to the sales column. The isNull function checks each row to see if the sales value is null, and if it is, the row is retained in the filtered data frame. This is particularly useful when you want to identify products or data points with missing sales figures, so you can take further actions such as imputing values, flagging them for review, or excluding them from specific analysis. When the filtered result is displayed using the show method, we see that only the row for product B is returned as it has a null value in the sales column. Product A and product C are excluded from the output because their sales values are not null. This example demonstrates how the isNull function helps in identifying rows with missing or incomplete data in a specific column, making it easy to address null values in your dataset. By filtering out rows with nulls, you can handle missing data more effectively in your data analysis and processing workflows. 2. Filtering rows with non-null values. In this example, we are using the isNotNull function in PySpark to filter rows where the sales column contains valid, non-null values. The data frame df consists of two columns, product underscore name and sales, with some rows containing missing or undefined sales data represented as non-null. Our goal is to retain only the rows where the sales values are present and not null. We accomplish this by applying the filter method along with the isNotNull function to the sales column. The isNotNull function checks each row to see if the sales value is not null, and if this condition is true, the row is retained in the filled data frame. This is especially useful when you want to focus only on the rows with complete and valid data, ensuring that null values do not interfere with your analysis or data transformations. When the result is displayed using the show method, the output includes only the rows for product A and product C, as both have non-null sales values of 500 and 700 respectively. The row for product B, which has a null value in the sales column, is excluded from the result. This example demonstrates how the isNotNull function helps you filter out rows with missing data and focus on the rows that contain meaningful, complete information. By using isNotNull, you can ensure that null values do not affect your calculations or analysis, enabling you to work with valid data more effectively. 3. Using isNull for data cleaning. In this example, we are using the when function in PySpark to replace null values in the sales column with 0. The data frame df contains two columns, product underscore name and sales, where some rows have missing or undefined sales data represented as null none. Our goal is to clean the dataset by replacing these null values with a default value of 0, ensuring that all rows have a valid sales value. To achieve this, we use the with column method to create a new version of the sales column. Inside the with column method, we apply the when function to check for null values in the sales column. The condition df.sales.isNull checks if the sales value is null. If this condition is true, the when function replaces the null value with 0. If the condition is false, i.e., the sales value is not null, the otherwise function ensures that the original sales value is retained. The result is a new data frame df underscore cleaned, where any null values in the sales column have been replaced with 0. When we display the result using the show method, we can see that the row for product B, which previously had a null value for sales, now shows a value of 0. The rows for product A and product C remain unchanged, as their sales values were not null. This example demonstrates how the when function can be used to clean your data by handling null values in a specific column. By replacing nulls with the default value, in this case 0, you can ensure that your dataset is complete and ready for further analysis without null values affecting calculations or other operations. 4. Combining isNull and isNotNull with other filters. In this example, we are using the filter method in PySpark to filter rows where the sales values are both greater than 400 and not null. The data frame df contains two columns, product underscore name and sales, with some rows containing null values in the sales column. Our goal is to retain only the rows where the sales column has non-nulls and the sales amount exceeds 400. To achieve this, we apply two conditions using the filter method. First, we use the isNotNull function to check whether the sales column contains non-null values. This ensures that only rows with valid non-null data are considered. Then we add the second condition df.sales 400 to filter the rows where the sales amount is greater than 400. These two conditions are combined using the AND operator, meaning both conditions must be true for a row to be included in the result. When we display the result using the show method, the output includes only the rows for product A with sales of 500 and product C with sales of 700, as these rows meet both conditions. The row for product B, which has a null value in the sales column, is excluded because it does not meet the first condition. This example illustrates how you can combine multiple conditions in PySpark to filter rows based on specific criteria. By using the isNotNull function along with the comparison condition like sales 400, you can efficiently filter your dataset to focus on rows that meet both data quality and value-based requirements. 5. Counting null and non-null values in a column. In this example, we are using PySpark to count the number of rows in the data frame df that have null values in the sales column, as well as the number of rows with non-null values. The data frame df contains two columns, product underscore name and sales, with some rows containing null values in the sales column. Our goal is to separately count how many rows have missing null sales data and how many have valid non-null sales data. To achieve this, we apply the filter method twice, once with the isNull function and once with the isNotNull function. First, we use the isNull function on the sales column to filter and count the rows where the sales value is null. The count method is then applied to return the total number of such rows, which is stored in the null underscore count variable. Next, we use the isNotNull function on the sales column to filter and count the rows where the sales value is non-null, storing the result in the not underscore null underscore count variable. Finally, we print the results using formatted strings to display the number of rows with null and non-null sales values. The print statements display these counts clearly, showing the total number of rows that have missing sales data and those that have valid sales data. This approach demonstrates how you can use PySpark to count rows based on specific conditions, such as identifying how many rows have null or non-null values in a column. By using the isNull and isNotNull functions along with the count method, you can easily quantify missing or complete data, which is particularly useful in data quality checks and analysis. 6. Using isNull and isNotNull with multiple columns. In this example, we are using PySpark's filter method to filter rows where both the product underscore name and sales columns contain non-null values. The data frame df consists of two columns, product underscore name and sales, with some rows potentially having null values in one or both columns. Our goal is to retain only the rows where neither the product underscore name nor the sales column contains null values, ensuring that we are working with complete data. To accomplish this, we use the isNotNull function on both the product underscore name and sales columns. The isNotNull function checks each row to see if the value in a specific column is not null. We combine these two conditions using the AND operator, meaning that both conditions must be true for a row to be included in the filter data frame. This ensures that only rows where both product underscore name and sales are non-null will be retained. When we display the filtered result using the show method, only rows where both columns have valid data are included. Rows with missing values in either the product underscore name or sales column will be excluded from the result. This example illustrates how the isNotNull function can be used to filter rows based on the presence of valid data across multiple columns. By combining multiple conditions with the operator, you can easily ensure that your dataset contains only complete and meaningful information, which is especially important when preparing data for analysis or further processing. That's it for today's tutorial on using the isNull and isNotNull functions in PySpark. As you've seen, handling null values is a key part of working with real-world datasets, and these functions make it easy to identify and manage missing data. Whether you are filtering nulls or replacing them with default values, PySpark provides a simple and effective way to clean and transform your data. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more PySpark tips and tutorials. Thanks for watching and see you in the next video.